Have you ever stopped to think about the fact that there are literally billions of pages, articles, and books out there in the world today? Yet, somehow, when you type a query into a search bar, you find exactly what you need in milliseconds. It's almost like magic, but of course it isn't. Behind every successful search is this incredibly fascinating, highly structured discipline that has been evolving for centuries. So today, we're jumping right into this explainer to uncover the invisible mechanics of subject indexing.
Here's our roadmap for today. We're covering 1. The GPS of knowledge. 2. From papyrus to computers. 3. Cataloging versus indexing. 4. The subject indexing process. And finally, 5. Measuring indexing success.
All right, let's kick things off with Section 1, the GPS of knowledge, navigating the sea of information.
Now, I want you to think about the last time you tried searching for a specific chapter in a massive reference book, or maybe a single data point buried deep in some vast digital archive. If you don't have a system in place, it is literally like looking for a needle in a haystack. It's frustrating, right? Because information without organization is, well, it's really just noise. The concepts might be right there in the text, but if we can't actually interpret and locate them, the whole communication process just completely breaks down.
And that brings us to the grand solution here: subject indexing. The word itself actually comes from the Latin indicare, which means to point out, guide, or direct. And that's exactly what it does. Think of it as a GPS for knowledge. It takes a raw concept, slaps a standardized term onto it, and gives you the exact address of where that concept lives in a massive document store. It completely bridges the gap between the words an author decided to use and the actual concepts you, the reader, are hunting for.
Moving right along to Section 2, from papyrus to computers, the evolution of search.
The technological leap we've made over the last 2 millennia is honestly staggering. Picture this. Back in the 1st century, ancient Romans were literally tying little slips of paper to papyrus scrolls just so you wouldn't have to unroll the entire thing to figure out what it was. Then, the printing press hits around 1450, giving us identical copies of books, which birthed the standard back-of-the-book index we all know. 1876 was another absolute game-changer. Both Melville Dewey and Charles Ammi Cutter dropped their foundational rules for cataloging, finally bringing some rigid standardization to the chaos. Fast forward to the 1950s, and you've got organizations like the CIA pioneering machine-produced keyword indexing. That literally set the stage for the digital search engines we can't live without today. But you know what's really wild? Despite the massive shift from physical scrolls to digital servers, the core goal hasn't changed one bit. We are fundamentally just trying to systematically organize human thought. Whether it's a 15th century scholar ranking subjects by hand or a modern algorithm crawling the web, the objective is always the same: organize ideas so we can retrieve them efficiently.
Let's look at Section 3, cataloging versus indexing, macro versus micro.
So, what's the difference here? Well, cataloging gives you the macro label for an entire book, while indexing dives deep into the micro concepts hidden inside it. Say a library gets a new book. They might assign it one big subject heading, like roses, or maybe a Dewey Decimal number. That is cataloging. But inside that book, there are probably hundreds of specific subtopics, right? Soil types, pruning techniques, climate zones. Pulling out those specific, highly detailed concepts and making them searchable, that is the meticulous micro-level work of indexing. And this brings us to the ultimate tug-of-war for indexers: exhaustivity versus specificity. Exhaustivity is like casting a massive net. You list every possible term associated with a document. Sure, you'll find everything, giving you high recall, but you're also going to drag up a ton of relevant noise, which completely tanks your precision. Specificity, on the other hand, demands highly targeted matching. It narrows the focus. You get super precise results, but you run the risk of missing broader, related items. Balancing these two, that is absolutely the highest art form of indexing policy. All right, Section 4, the subject indexing process, popping the hood. Let's actually pop the hood and look at Ranganathan's core workflow. It's essentially a 3-step process. Step 1 is conceptual analysis. The indexer examines the title, the abstract, the intro, even the image captions just to establish the core subject content. Step 2 is identifying the principal concepts, asking, okay, what is this text actually about? And then Step 3 is the translation phase. This is where the indexer takes those raw concepts and translates them into a highly controlled indexing language. This ensures all those synonyms and related terms are uniformly categorized so you, the user, can actually find the stuff. But hey, we have to remember the human element here. Behind every perfectly organized database is a subjective human mind, which means, yep, the process is entirely prone to human error.
An indexer might completely misinterpret what the author meant, forget a crucial term, or use a really broad term when they should have been specific. I mean, imagine miscategorizing a research paper on Apple, the fruit, as Apple, the tech company. And perhaps most importantly, they might just fail to anticipate what their target audience is actually going to type into the search bar. Because at the end of the day, indexing isn't just about reading documents, it's about predicting human behavior.
Which brings us to our final section, 5, measuring indexing success, testing the engine's horsepower. So, how do we know if our indexing engine is actually working? The first major metric is recall. Recall is simply a measure of completeness. It tests if the system successfully retrieved all the relevant documents that actually exist in the collection. Let's say a database has exactly 100 articles on a topic, but your search only finds 50 of them. Well, your recall is a pretty poor 50%. A high recall system makes absolutely sure nothing slips through the cracks.
Precision, on the other hand, is like the bouncer at the door. It measures the system's ability to filter out the noise. If your search brings back 100 documents, but only 10 of them are actually what you are looking for, well, you've got a massive waste of time on your hands. Precision ensures that the system holds back all that irrelevant junk, handing you a laser-focused set of results. You can see it really clearly in this matrix right here. Box A represents your hits. Those are the relevant documents you successfully found. Box B is your noise, all the irrelevant junk you accidentally pulled up. By crunching the numbers between these boxes, system managers can perfectly calculate both the recall and the precision, allowing them to constantly tweak the engine and give users the best possible experience. So, I'm going to leave you with this final thought. We've seen just how meticulously humans have designed these indexing systems to capture context and meaning over the centuries. But today, we generate more content in a single day than ancient civilizations did in a lifetime. As the web just absolutely explodes with content, will the subjective human mind remain the ultimate engine of discovery? Or is artificial intelligence finally ready to take the wheel? It's a huge question, and it's definitely going to define how we organize and access knowledge in the future. Thanks so much for joining me on this explainer, and I'll catch you in the next one.